Okay, we're going to look at parallel lines, and I'm going to try to show you these lines before I start writing. So look at these three lines I have, a green, a blue, and a red one. If you look at A, we're going to graph those lines, and those three lines actually are A, B, and C. So if you look at A, the slope is 2, and it goes through the y-intercept is 2. Oh, I can't. Let's see if I can. Can I drag these? I can't drag them. Oh, that sucks. Oh, I can. Whew. Okay, so I go through the y-intercept at 2, and my slope is 2, so my green line goes up 2 over 1, up 2 over 1, because that's a slope of 2. Okay, so that's A. B, my blue line, goes through the y-intercept origin, 0, 0, but the slope is also 2. So if I make this line go through the origin, I still have a slope going up 2 over 1, up 2 over 1, but it goes through the origin. And my last one has a slope of 2, but goes through -1. So if I make it go through -1, it still goes up 2 over 1. So if you'll notice, these three lines are parallel, and we'll talk about the equations in 1 second. So let's go look at the second one down here, because I also made these lines. These equations, notice you're going to have to solve for y. So for A, you're going to divide everything by 2. So your slope ends up being -1/2, and the y-intercept is 2. So I'll take my, now I forgot, red line, and I'm going to make it go through 2, and it's got a negative slope, so it's going the other way, and it has a slope of -1/2, so it goes up 1 over 2, up 1 over 2. So there's line A. Line B, I'm dividing everything by 2 again, and it goes through the y-intercept, and also has a slope of -1/2. So it goes through kind of the y-intercept, close enough, and it goes up 1 over 2, up 1 over 2, has -1/2 for the slope. And C, if you subtract 1/2 from both sides, you end up with -1/2 x minus 1. So that's going to be our green line. And we're going to take it to the -1 for the y-intercept. Not like that. And it also has a slope of -1/2, because it goes up 1 over 2 in the negative direction. So if you can see these three lines and hopefully notice what's the same about them, if you haven't already put it in your notes, we will put it in our notes right now. Okay, so I have my three lines. Hopefully you notice about the lines that they're parallel. They have the same slope. They have a positive slope. The slope is equal to 2. Okay, and if you look at the equations, hopefully you notice that they all had 2x. So that means that m equals 2. So when you're looking at equations that have the exact same slope but different intercepts, the slopes are always going to be the same. So I was thinking about one other thing to notice about, oh, they all have different y-intercepts. So these are different. But the slope is the same. Okay, let's see if it's true for number 2, which I hope you already figured out it is. Okay, so what I did in number 2 while I was talking to you before was I divided everything by 2, which means that we have y equals, ooh, and that should be 1. So actually, just pretend like my red line is down here because I put it up too high. But the slope is negative 1/2. Okay, b, we did the same thing. We divide by 2. And you see that negative x divided by 2 is the same as 1/2 x, negative 1/2 x. And then in C, you subtract 1/2 x from both sides, and you end up with your slope here, and your y-intercept is negative 1. So when you look at the lines, you should notice that they have a negative slope. M is negative 1/2. They're parallel. And that's all. And when you look at the equations for the line, you notice that the y-intercept, or b, changes, but the slope is the same. So guess what we know about parallel line slopes? The slopes are always the same. Always the same. So if I can figure out the slope, I can always find another line that's parallel because the slopes are going to be the same. So we'll do a little practice. We have a table, and we're looking for the slope of the line for these points. I can pick any 2 points. I will go ahead and pick these 2 points. So from -3 to 1, it's going up by 4. And from 28 to 12, it's going down by 16. So my slope is -16 over 4, which is equal to -4. So the slope of the parallel line is also going to be -4. And it's really -4 over 1 because I'm going to go up 4 over 1 in the negative direction. Okay, so here's the slope of lines that are parallel. Okay, what if I have 2 points from a linear function? Then I have x1, y1, x2, y2. The slope is 14 minus 8, and the denominator is 4 minus 2. 14 minus 8 is 6. 4 minus 2 is 2. So the slope is 6 over 2, which is 3. And the parallel line also is going to have a slope of 3. Okay, isn't that amazing? And now you know how to find parallel lines. Okay, so here's a graph. We're going to have fun slope. I'm going to find perfect points, pretty points, whatever. And there's one there, and there's one there, and there's one there. So the line is positive, the slope is positive, and it's going up 1 over 2. So that's going to be 1/2. And the slope of a parallel line is also going to be 1/2. So if I want to write an equation for a line parallel to line A, which I'm assuming is this line right here, I'm passing through point 11, excuse me, which is right there. Then I'm going to use my point slope form. Y minus y1 equals m times x minus x1. Here's my x1, y1. So I have y minus 1 equals 1/2 x minus 1. So my equation could be y minus 1 equals 1/2 x minus 1. And if I wanted to simplify it to make it slope-intercept form, which it doesn't ask for, but we'll do it anyway, I would distribute. So I would have y minus 1 equals 1/2 x minus 1/2. I would add 1 to both sides. I would end up with y equals 1/2 x plus 1/2, because minus 1 minus 1/2 is going to be 1/2. So same equation, different form. These are the same. Okay, let's look at the next one. Now I have a linear equation that's y equals 8. And my first thought is that is hoi, because it's y equals. So it's a horizontal line and the slope is 0. So any line that's parallel to that is going to have a 0 slope. So if I am looking for a parallel line, I can use, and that's the intercept. So I could say y equals 3 is going to be my answer. And if you want to do y minus 3 equals 0 times x minus 0, all that turns into a 0. So y minus 3 equals 0. And that would make y equals 3. Okay, but since I know it's a horizontal line with a 0 slope and it's y equals, I could just take my y number right here and write y equals 3. I don't need to do any of that unless you want to. Okay. Number 7. These are going to be fast notes. Okay, so this one says it must be slope-intercept, and I have my x1, y1, and I have a line that I want to be parallel to this, but I don't have the slope, and you do see that it's not 4 or 5. Or it might be 4. Okay, it's 4. Let's go ahead and solve for y. So we're going to have minus 4x on both sides. Negative y equals negative 4x minus 5. I forgot that y was negative, which makes them all change. Here's what I'm going to do. I'm multiplying the whole thing times negative 1, and basically I'm distributing across everything. So I have y equals 4x plus 5. So when my y is negative, I change the sign of everything. You can think about multiplying everything times negative 1, or just say, I'm going to take the opposite of y, therefore I have to take the opposite of everything, which makes y equals 4x plus 5. And so my slope is 4, which is the whole thing I needed anyway. So let's go back over to our x1, y1. So I have y plus 8 because it's a negative, and that's equal to 4 times x minus 4. Y plus 8 equals 4x minus 16. Take 8 away from both sides. Y equals 4x minus 24. And that's point slope form, and that slope intercept form, and that's what they asked for. Okay. So we're going to have another equation to write. Once I see this, I know that I've got the x. My slope is undefined. It's a vertical line. It's going to be x equals. So if I'm looking for another vertical line, I have x equals, and all I need to write is x equals 4, because that's my x value. And I know because it's Vux that my equation is just going to be x equals. Okay, number 9, standard form. This one's already solved, so my slope is negative 5. I have x1, y1. So I have y minus 3 equals negative 5 times x minus 1. I'm going to distribute. Y minus 3 equals minus 5x plus 5. So I need to get my x and my y over on the left. So I'm going to add 5x to both sides. 5x plus y minus 3 equals 5. I'm going to add 3 to both sides. 5x plus y equals 8 is my equation in standard form. I think that's all. Whoa! And there's your practice on parallel lines. We're going to leave that till tomorrow. Okay, so important information. Parallel lines have the same slope. So we can use any of our equations, standard form, point slope, or slope intercept, and write equations for lines. That are parallel by making sure our slopes are equal. Pretty straightforward and easy. Bye.